All right, welcome back. We are going to finish chapter 5, so we'll call this our 5B unit. This first day, it does say day 10 in your notes, but it is actually day 11, and we're going to separate it into 2 days. One is graphing square roots, and then the other is graphing cube roots. So today we're just going to be looking at graphing square root functions. So number 1, it says complete the table of value for the function f of x equals radical x. So this is asking us to first look at our table of values. So you can create them on your own. You can create them on your table on your graphing calculator if you choose to do that. That's where you will type this into your y1. We can do this quickly without looking at our calculator because you guys can do square roots. Square root of -4. I know some of you might be thinking, oh, we can do imaginary numbers. This is all dealing with real numbers, okay? We have a real graph over to our right here. So we're not going to be graphing i's. So we would say that this is undefined because we can't take the square root of a negative. So there, and there, okay? Oops, undefined. Square root of 0 is 0. Square root of 1 is 1. Square root of 2, square root of 3, we don't know those exactly. And square root of 4, we know is 2. So if we did go to our table of values, you would see our first 4 in our table is going to say error because that's how our calculator will do the square root of a negative. And then at square root of 2 and square root of 3, it's going to be 1 point something because it has to be somewhere between 1 and 2. The exact value of square root of 2 is square root of 2. Okay, the exact value of square root of 3 is square root of 3. Our rounded values, so for like square root of 2 is 1.414, and the square root of 3 is 1.732. Okay, again, those are rounded. So it says, what do you notice about some of the values? Hopefully we notice that some give us errors or undefined. If you typed it into the function, tried to evaluate it for some, what message appeared? That's the error because you can't take the square root of a negative. So now let's look at our graph, okay? So your first point is 0, 0. Your next point is 1, 1. Your next point that's exactly on a corner of the grid is 4, 2. Okay? And without looking at our table, our next one that would be on a perfect corner would be 9, 3. Why 9, 3? Because the square root of 9 is 3. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So that would be your next point. Your next one after that would be 16, 4 and 25, 5 because those are all perfect square roots. Any values between 4 and 9 will be 2 point something, right? Any value between 9 and 16 will be 3 point something. We don't need to graph all that, okay? So what's going to be important as we look at graphing square roots using transformations is your main point. This is a main point. That's your starting. Then your next one, you have 1, 1. And your next one is 4, 2. And that'll be plenty enough to graph, okay? But this right here is your starting point. So it says, what is the domain? Notice you have no points over here. You can't take the square root of a negative. So your domain starts at 0 and goes to infinity. And at your range, notice you have nothing negative because the square root of a number is always going to be positive. So that's also 0 to infinity, okay? Obviously, if there was a negative in front, that would be a reflection, okay? And we're going to look at our transformations using what we learned, first quarter of the year, okay? So back in the fall. So that is number 2. It says, consider this function the square root using your knowledge of transformations. And you guys did such a great job at transformations. This should not be too tough, okay? So remember, as a refresher, anything inside the function affects the function horizontally. So it deals with the x's. Anything outside the function affects it vertically, which changes the y values. So using your knowledge, let's talk about what's happening here. Our function here is going to go to the left 2, and then that one outside, remember it affects the y value, that's going to go up 3. So every single point up here on this main graph is going to go left 2, up 3. So the first one that you should start with is, like I said, that starting point 0, 0, okay? So instead of starting at 0, 0, we are going to start left 2, up 1, 2, 3. So your starting point here is negative 2, comma 3. Then from there, you are literally copying that graph up above and just putting it there, okay? So think about your point 1, 1. You're still going to go left 2, up 3. So again, think about if your next point was typically 1, 1. You're going to go left 2, up 1, 2, 3. That's that point there. And really, that's enough to get your graph. And you can see it on your calculator as well. So notice now your domain and range have changed. That blue, that's inside the function, that affects your domain because that affects your x values. So instead of being 0 to infinity, it's negative 2 to infinity because it went left. Anything outside affects your range. Why your range? Because those are your y values. Instead of being 0 to infinity, it's now 3 to infinity. Okay? I want you to pause the video, and I want you to just list the transformations. You have 3 things happening here, and you need to be careful. Okay? I'm going to highlight all of them. Let's stick with blue underneath. You have this, you have that, and then you have this. Just list those 3 things. Okay? So pause it. Okay, so your 3 transformations, starting with that negative inside, it's a horizontal reflection, so that means it's over our y-axis. It's changing your x values, not your y's. Your next one is a horizontal shift right 1, and then your last one is your vertical shift down 4. And you might be asking, why is it right 1? I wrote down left 1, and that's because of that negative in front. So there's 2 ways to think about this, and this is something you definitely may have forgotten since the beginning of the year. Okay, we can write this 2 ways. We can write this as a negative x minus 1, and that's how you see that it is going right 1. The other thing you can do is, so all we're doing there is factoring out that negative for the reflection, and then this is your horizontal shift. The other thing is you can take what's underneath, including that negative, and if you set that equal to 0 and solve, you get negative x equals negative 1, divide by negative x, and you get x equals a positive 1. That's why it's going right. So there's 2 ways to figure out that shift, and you only have to be extra careful if there's a coefficient in front of the x, and in this case there's a negative coefficient in front of the x. Okay, so at that point I would say graph it, and if you want you can throw it into your calculator, but we can also do this without our calculator. So first things first, 0, 0 you can't reflect, okay, but you can shift it to the right 1, which would be here, and down 4. So that's your starting point. Okay, that's your 0, 0, but moved. Now your next point is typically your 1, 1, which is here. First things first, reflect it over the y-axis, which puts it here. Right? Everyone there? Because I'm going to erase this other part. So we took that 1, 1 and we reflected it over the y-axis, and now it's there. Next step, we're going to shift it right 1. So now we're back here. So I'm going to erase that. And then last and final step, we're going to move it down 4. So 1, 2, 3, 4. And that is your 1, 1 point. Okay, so this was our 0, 0, and that's your 1, 1. That's now shifted, right? So let's go back through that so you can follow that happening. Your 1, 1 starts here. First thing we do is we reflect it over, so now it's here. We move it right 1, so now it's here, and then you move it down 4, which puts it at that point. Technically, that's enough of your points because there was no vertical stretches or shrinks to see your graph. Okay, and you would see that on your calculator. So now your domain's a little bit different because notice it's all negative. So your smallest x value is actually going to be negative infinity until your x value here, which is 1, 1, 2, 3, 4. And so until it reaches 1. In your range, your lowest range is still negative 4. and it is going to go up to infinity. Okay? All right, flip over to the next page. And this one, notice this looks a little different. It's 9 minus x squared. Okay, so what I want you to do is plug this into your y1 and fill in your table. So pause the video, fill in your table. Okay, so here's your table and here's your graph. On your calculator of your graph, yours might not connect to the points 3, 0, but we can clearly see that that is part of our function. So you can't just only rely on your graph. You do have to rely on your knowledge of square roots. And 9 minus 3 squared, it is 0. You can take the square root of 0. So this is a little different. Notice you have nothing over here. You have nothing over here. Okay? You have nothing underneath the x-axis either. So when looking at your domain, the farthest left that this goes is -3, and you do have an output of 0, so that's why there's a bracket. Farthest right is 3, you do have an output, that's why it's a bracket. What is the range of the function? Notice your lowest is at 0, so it's right here. Your highest is at 3. And then in question 5, 6, and, okay, 7 we're going to definitely pick up tomorrow. 5, it says, using the 3 examples above, make a conjecture about the domain. The easiest way to know what your domain is without looking at your calculator, no matter what is underneath here, whether it's x plus 5, whether it's just x, whether it's -x plus 1, you set that greater than or equal to 0 and solve. So if we set x plus 5 greater than or equal to 0 and solve, we get x must be greater than or equal to -5. If you set this greater than or equal to 0 and solve, and remember, when you divide by a negative, you flip your sign. X must be less than or equal to 1. So that's the easiest way to get your domain without looking at your table or your graph. Whatever's underneath your square root, you have to set it greater than or equal to 0 because you cannot take the square root of a negative. And then it says, use your conjecture to determine the domain of the function 2x plus 5 without graphing it. Check your solution by graphing it on a calculator. Try that. Take your 2x plus 5, set it greater than or equal to 0, and solve. So pause it and do that. And if you thought about where that would be getting shifted, if you set that underneath equal to 0 and solved, you get x equals -5 halves. This function is shifting 5 halves to the left. That's why your domain has also shifted 5 halves to the left. Okay? Tomorrow we'll pick up with questions 7 and 8 and look at cube roots, which will follow this very nicely. So it'll be a short, quick video. And remember, anything you missed on this, you can pause it and re-listen to it. Okay? All right, have a good day.